Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Sridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our class 12th physics playlist we will study the magnetic field of Earth and will understand all three representative parameters of Earth or terrestrial magnetism, that are angle of declination, angle of dip or inclination, and horizontal component of Earth magnetic field, and we will also understand the phenomena of northern lights or Aurora borealis or beautiful dancing waves of light. Let's start our study of magnetic field of Earth. The presence of magnetic field on Earth's surface by Earth itself is called as terrestrial magnetism. Gilbert was the first scientist who pointed out in year 1600 that Earth itself is a magnet. Terrestrial magnetism is presence of magnetic field effect on surface of Earth where a freely suspended compass needle aligns itself in south-north direction, and even when we deviate that magnet, it again retain that south-north alignment. Similarly, when we embed a soft iron piece in Earth crust in some time period, it get magnetized and behave like a magnet, and we got magnetic neutrality position at a specified location near source of magnetism current, which indicate that apart from magnetic field of that current source, there is one another equal and opposite magnetic field of Earth act there. The value of magnetic field flux density on Earth's surface near equator is just half of magnetic field flux density on surface near poles, and that gives a resemblance that a huge size powerful bar magnet remain embedded in Earth core, and that produce magnetic effect on Earth's surface. The terrestrial magnetism not only exists on the surface of Earth, it extends far and wide in atmosphere too, but it is very weak in terms of magnetic field flux density, and the value of magnetic field flux density of Earth magnetism is very small. It is of the order of few Gauss, and 1 Gauss is 10⁻⁴ Tesla, and in Indian capital Delhi the magnetic field flux density is only 0.4 Gauss or 0.4 into 10⁻⁴ Tesla. As a simplified explanation of terrestrial magnetism, Earth behave like a huge size bar magnet whose magnetic south polarity exists in geographically north position, and this south polarity magnetic pole is termed as magnetic north pole as it is geographically in northern direction, and similarly in southern direction the magnetic pole is called as southern magnetic pole, but its polarity is just like a north magnetic pole. And for a bar magnet, magnetic force lines come out of north pole and travel on the surface of Earth from south to north direction and enters in northern directed pole. So on the surface of Earth, the terrestrial magnetism or magnetic field of Earth is directed from south to north direction. The terrestrial magnetism is very complex, and observed data on different space and time positions are very contradictory, and no single theory can explain origin, behavior or nature of terrestrial magnetism in complete sense. To explain source of terrestrial magnetism, popularly it is believed that outer space, high energetic cosmic rays ionize Earth atmosphere, and axial rotation of Earth and relative position of atmospheric ion position and Earth surface generate a strong current effect, and due to those currents of atmospheric ions due to axial rotation of Earth, we observe terrestrial magnetism surrounding the Earth. Now another hypothesis assumes that within Earth, iron and nickel and their alloys are present in liquid form, and these ferromagnetic material with axial rotation of Earth produce conduction current in molten mass, and that current behavior produce terrestrial magnetic effect. Now terrestrial magnetism have different observed phenomena, but it is also beneficial to our life too, and it saves our Earth from solar wind and excessive scattering of high energetic ionized particles, and due to this terrestrial magnetism we would have survival of ozone layer in our top atmosphere, and that ozone layer helps and absorb dangerous solar wind effect or energetic ionized particles. So we can say that Earth magnetic field give us a protection barrier, and that reduce exposure of solar radiation and energetic ionized particle of outer space to a safe limit. The terrestrial magnetism is explained by three key elements, and they are angle of declination, angle of depth, and horizontal component of Earth magnetic field. Let's first understand angle of declination. Our Earth acts as a huge size spherical body which spin about its own axis, and two ends of axis of rotation are called as geographical poles. One in northern direction is called as geographical north pole, and second in south direction is called as geographical south pole, and a vertical plane passing through line joining these poles on the surface of Earth is called as geographical meridian. When a compass needle, which is a tiny but strong magnet pivoted on vertical axis and can rotate in horizontal plane, is suspended freely, it won't align itself in geographical north and south pole axis, but its axis makes an angle with geographical meridian, and this angle is roughly about 11.5 degree, and that angle varies at different position on Earth, and at the same position it also changes when observed at different times too. Now this axis of freely suspended compass needle is known as magnetic axis. Here in this diagram, this green line is geographical axis of Earth rotation, and this is geographical north pole, whereas this axis of freely suspended compass needle is magnetic axis of Earth magnetic field, and extreme end of this axial position on Earth is magnetic north pole, and position of magnetic north pole somewhere in Canada is shifted westward from geographical north pole, as it is clear in this diagram. Earlier and even up to 1990s, the North Geomagnetic Pole is located in Ellesmere Island of Canada to the western side of axis of rotation, but scientists found that our North Magnetic Pole has been moving towards north, and in 2017 it has passed the geographic North Pole, and now it is heading towards south to the western side of axis of rotation towards Siberian part of Russia, and this shift of magnetic north pole is very strange and still not exactly known to our scientific world. The axis joining geographical north and geographical south pole is called as axis of rotation, and any vertical plane passing through that axis on Earth's surface is called geographical meridian, or any plane parallel to this vertical plane is also called as geographical meridian, and another vertical plane on the surface of Earth along the axis of freely suspended magnet is called magnetic meridian. So magnetic meridian connect magnetic north pole and magnetic south pole on magnetic axis, and the angle between geographical meridian and magnetic meridian is called angle of declination of that position, and this value of angle of declination is not the same for different positions on Earth's surface, and for the same position the angle of declination also changes with time. The value of angle of declination is not the same at different position on Earth's surface. The value of declination angle is relatively greater near poles at higher latitudes, and it is quite small near equator, as India is close to equator, and the declination in India is small, and it being only 0 degree 41 minutes towards east side at Delhi and 0 degree 58 minutes west side at Mumbai. So in such small angle of declination conditions, the axis of freely suspended magnet and north end position and geographical north pole positions are quite close to each other, but when angle of declination is relatively higher and even variable, the information about angle of declination is very important for correction of navigation, as it is observed by compass needle, and compass needle is not showing the exact axial position of geographical meridian, and the two, geographical meridian and magnetic meridian, got angle of declination, and with that information of angle of declination we can find out exact geographic meridian at that position by information of magnetic meridian. Another significant element of terrestrial magnetism is angle of depth. If a magnetic needle is perfectly balanced about its horizontal axis and it is pivoted such that it can swing in a vertical plane of its magnetic meridian, then the axis of swinging magnet will make an angle with horizontal, and this angle of axis of freely swinging magnet in magnetic meridian with the horizontal is known as angle of dip, and we also call angle of dip as inclination, and it is denoted by symbol delta. The axis of freely swinging magnet in magnetic meridian indicate the direction of total magnetic field of Earth, and angle of dip is the angle of resultant magnetic field of Earth with horizontal line. It means we can resolve the total magnetic field of Earth represented as B here in two components, one along horizontal line known as horizontal component of Earth magnetic field and another along vertical line known as vertical component of Earth magnetic field. If the angle of dip is delta, then the horizontal component of Earth magnetic field H will become cos delta component of total magnetic field, so H become B cos delta, and similarly the vertical component of Earth magnetic field V will become B sin delta. So horizontal component H is B cos delta and vertical component V is B sin delta. If a needle is free to move in an horizontal plane, then its axis will align along magnetic meridian, and in magnetic meridian if it can freely swing in vertical plane, then it will also have angle of dip with horizontal line, and it means this needle have two driving force of terrestrial magnetism, one of magnetic pole situated in northern direction in north direction, and second is a downward dip force, and as per resultant position of the two forces, dip needle makes an angle dip angle with horizontal line, and accordingly we can say that the resultant total magnetic field of Earth have two component, one along horizontal line H B cos delta and second in vertical downward direction in northern hemisphere V equal to B sin theta. And if this needle is suspended near equator, then it will take a perfect horizontal alignment as the both side of this needle get identical amount of dip force from both northern side magnetic pole and southern side magnetic pole, and as an equilibrium it rests along horizontal line and its angle of dip in that condition become 0, and with dip angle 0 cos 0 become 1, and entire resultant magnetic field of Earth become its horizontal component, and for dip angle 0 sin delta becomes 0, and at equator vertical component of Earth magnetic field become 0. If the same needle in vertical plane of magnetic meridian is allowed to swing, it will take perfect vertical position at northern directed magnetic pole, as south magnetic polarity of that northern magnetic pole attract north pole of suspended dip needle in perfect vertical direction, and at pole the angle of dip become maximum 90 degree and cos 90 will become 0, and horizontal component of Earth magnetic field at pole becomes 0, and the entire resultant magnetic field of Earth become the vertical component at poles. So at pole there exists only vertical component of Earth magnetic field, and at equator there exists only horizontal component of Earth magnetic field. Whereas elsewhere when angle of dip is neither 0 nor 90 degree, both horizontal and vertical component of Earth magnetic field coexist. If a dip needle is free to swing in magnetic meridian, then at equator it will take a perfect horizontal line and the north pole of dip needle coincide with north direction. But if we move to the north side of equator in northern hemisphere, the dip needle will tilt in downward direction, and at certain position if axis of dip needle makes an angle delta dip angle with horizontal, then it clearly indicate that total resultant magnetic field of Earth had one north directed horizontal component but another vertical downward vertical component of Earth magnetic field, and the magnitude of dip angle and vertical component of Earth magnetic field goes on increasing and become maximum at north directed magnetic pole of terrestrial magnetism, and at pole there exists only vertical component of magnetic field and that too maximum, whereas to the south side of equator in southern hemisphere the south pole of dip needle go downside, and this will clearly indicate that vertical component of Earth magnetic field in southern hemisphere will become upward, whereas in northern hemisphere the vertical component of Earth magnetic field is in downward direction. So to describe terrestrial magnetism or magnetic field of Earth at any position on Earth's surface, we specify three quantities, and they are angle of declination, angle of inclination or angle of dip, and horizontal component of Earth magnetic field. This angle of declination is angle between geographical meridian and magnetic meridian, whereas angle of inclination or angle of dip is angle of dip needle with horizontal line, and horizontal component H is resultant magnetic field component in the direction of north on surface of Earth along horizontal line, and these three H, delta and alpha are known as element of terrestrial magnetism. It is given that angle of dip at any position on Earth's surface delta is 60 degree, and horizontal component of Earth magnetic field H at that position is 0.3 Gauss or 0.3 into 10⁻⁻⁴ Tesla. We have to find out the vertical component of Earth magnetic field at that point. So we know horizontal component of Earth magnetic field is B times cos delta, where delta is angle of dip. So the total magnetic field can be obtained as a ratio of horizontal component of Earth magnetic field and cos delta, and angle of dip delta is 60 degree, cos 60 is half, and when horizontal component of Earth magnetic field given as 0.3 into 10⁻⁻⁴ Tesla is divided by half, the resultant total magnetic field of Earth at that position will become double, 0.6 into 10⁻⁴ Tesla. Now the vertical component of Earth magnetic field V can be obtained as total magnetic field of Earth multiplied by sine delta, and angle of dip is given 60 degree, sine 60 is √3 by 2, and when sine 60 is multiplied by total resultant magnetic field of Earth, the vertical component of Earth magnetic field will become 0.3 into √3 into 10⁻⁴ Tesla. Terrestrial magnetism or magnetic field of Earth produce several natural phenomena on our surface and in our atmosphere. Some of those phenomena are very strange and nobody knows the exact answer of those phenomena, and some are very interesting, and one such is northern lights or Aurora borealis, or beautiful dancing waves of light which are produced at northern and southern magnetic pole of Earth. Now reason of those lights is releasing of energy by charged particles of both positive and negative nature when they accumulate near poles, and the accumulation is caused by terrestrial magnetism. The vertical downfalling positive and negative charged particle or ions experience magnetic force by horizontal component of Earth magnetic field, which is directed from south to north, and by that magnetic force action, downward falling positive charge will shift towards eastward direction, and downward falling negative charge will shift themselves in westward direction. We can prove this by Fleming left hand rule. The thumb, forefinger and middle finger of left hand are stretched perpendicular to each other as shown here, and this forefinger indicate horizontal component of Earth magnetic field from south to north, and for vertical downward motion of negative charge, the corresponding positive charge motion is vertical upward, and this middle finger indicate the direction of motion of positive charge. Then the thumb of left hand indicate the direction of force on this downward falling negative charge in westward direction, and similarly downward falling positive charge have force will have tilt towards east direction. Now when downward falling positive charge by horizontal component of Earth magnetic field shift towards east direction, this east moving positive charge in northern hemisphere experience magnetic force through vertical component of magnetic field which is acting vertically downward, and in this vertical downward magnetic field east moving positive charge have a north directed force, and this downfalling positive charge shifting to east also move towards north, and ultimately all charges falling downward shift to north pole position. Likewise, this downfalling negative charge when got west directed movement in vertical downward Earth magnetic field, it would also have a force in the direction of north towards pole. So both positive and negative charge falling down respectively shift positive to east direction and negative to west direction to generate again magnetic force in the direction of north, and ultimately all charges accumulate together at pole position where they produce a very interesting, amazing aurora of dancing lights as illustrated in this picture here. We hope this learning video has explained all important aspects of terrestrial magnetism. You now understand the probable source of magnetic field of Earth. You can understand how the three element, angle of declination, angle of dip and horizontal component of Earth magnetic field specify terrestrial magnetism. You also understand how horizontal component and vertical component of Earth magnetic field varies at different angle of dip positions, especially at equator and poles. And you could also understood the reason of magnificent northern lights or aurora of borealis, or how the beautiful dancing wave of lights are produced at northern and southern poles. Our other learning video of the same playlist are equally useful, and you can use them in your studies or share them to your friends. Have nice time. Happy learning. Thank you very much.